Hello guys, welcome back to my channel. If you're new to this channel, please do subscribe and click the notification bell so you can get notified whenever we drop a new video on this channel to help you with your um, basically every online issues you might be having and you need help with. Today we will be looking at the tax 0 times 09 static library from ALX. This tax is one that has proved stubborn to a lot of people, but I want to tell you it's quite simple. It's just you need to just follow gradually what the instruction has said. You'll be able to answer your tax 100%. There's actually nothing. There's actually no big deal here. Just pay attention, and we'll all be doing this together. Okay? Thank you very much. So, that being said, let's start from the beginning. I encourage you, please, as I always do, go over the resources, make sure you understand, take your time. ALX is a program that they need you to, they embed a lot in the resources. So you take your time, read through, search resources, research online, go out of what they've given you, understand exactly what they are saying. You will see that most of these tasks are actually very simple, and it's just time consuming. But if this is something you've dedicated your time to do, just go over it, go full time into it, and then you will enjoy the dividend, I assure you. All right, so we'll be needing all of this, the AR, the random library, the NM, to test some of the codes that we are going to be creating. All right, go over the general requirements. You'll be needing your VI. You'll be compiling your code using GCC with the WRL and the WExtra. You need a README in this task. You need to have your putchar. You need to create a putchar file for this task. You also need to have a main.c in this task, and don't forget you need to have your main.h where all your prototype will be included. Without the main.h file that contains all the prototype, your code will not run. So be sure to include that. The things you're allowed to use: the vim, the vi, your readme, and don't forget your shebang code, because most of the codes are going to be executed in bash. So don't forget your shebang code when you're typing in your C codes. Alright, that being said, let's quickly go. Today the task is actually lengthy, so just be sure to follow step by step so that you understand what you are required to do and you get your marks 100%. You won't fail anyone. Alright, so for those that are having problem with the quiz, let's quickly go over them. So what command is used to create static library? Of course, is AR. What command can be used to test the symbols stored in a static library? AR and NM. We're going to be using them in this task. What is the format of a static library? It's an archive. What is the point of a random library? It's called ranlib. Random library is to index and archive. Basically, the essence of creating a static library is to have most of your code in a particular place where you can call it, and then you can actually link it to an application that you are working on to perform whatever function it is that is embedded in the code that you stored in your static library. So that's just the basic necessity of a static library. Just have it there. The object files has to just be inside there, so you can always call it whenever you need it. That's why you're creating it. It's more or less having, how will I say, a bank of knowledge. Just like the word says, library. your books, everything is inside there. Everything you need is just there. You just, whenever you need something, you just go there and pick it. So that's the essence of creating a static library. It can be linked to an application when you're building one, and then you just give off that which you want. All right. So that being said, let's quickly uh, go to the tags. Remember, I said you need to create your picture. Um, and you need to create the files, the main.h file that's required. So first, let's quickly. I'm using Git Bash for this project. You can choose to use your webcam. I am using Git Bash. So once we get here, let's ls and see what we have in here. So we'll be needing, number one, first of all, we need to cd into this repository. It's here. You need to cd into this repo, ALX low level programming. You need to cd into the repo that you already created. So we cd into ALX low level programming here. So once this is done, let's ls and see what we have in there. So here we are. The next thing you do after you cd into the ALX low level programming is to create this directory 0x09 static library. That's the next step. You create this directory. We all know how to do that. mkdir. I like to copy so I don't make mistake. One single error. This s, if you make a mistake and remove it and you create it, checker would mark you wrong, and this just might affect everything you are doing on the program, so on the tags. So be sure to get everything you are copying correctly. If there is a dot that is missing, make sure that that dot is included. Otherwise, you just be wondering where all your errors are coming from. That's programming for you. One dot can cause a lot of problems. So just be sure to make sure that your spellings are correct. So this file will not create. This directory will not create. Why? Because I already have it in my this thing here. I already have it, so it will not create here. All right. So what next are we gonna be doing once this is created? The first thing is to create your readme. Before I proceed, I would like to let you know that I have a Google document that has all the code that you would be needing for this task. Every single code is here on the Google document. They are quite long, so you just go through them, copy them the way they are, and you can paste where you need to create them. So I think the first thing we need to do here is to create a readme. Once you cd into this and you've created your directory, once you create your directory, you need to cd into the directory. Okay, you cd into the directory. Once you cd into the directory, the next thing you might need to do is to create a readme using vi. You create a readme using vi. Okay, you create a readme using vi. Sorry about that. So let's quickly vi create readme.md. So I just quickly just did something here. This is not what should be here. You know how to just put the content in here. I just decided to do this. Forgive that. So you get your you can actually put anything here. The idea of readme is just to describe what you are doing in the project. What I do basically is I go to the tags, and then I copy I copy the explanation given at the top of some of these things here, and then I paste them down in that readme box. That kind of gives a description of what I am doing to anybody that is looking at it. So once my readme is created, the next thing I want to do is to create my main.h. I like to create all these funny files first before I go into other ones. I would like to create my main.h. The reason for this is I don't want to forget it. Anytime I'm creating the C tags, knowing that the main.h contains the prototype, I don't want to just assume that I'll create it later and then you forget, and then all your files just start checking error. It's frustrating sometimes. So I tend to create my main.h, create my putchar, create my readme. All these files, I create them first before I even go and start creating any other thing that I need to create. So at VI, I create my main.h. What do I do next? I create my putchar underscore putchar.h. Here we are. Sorry, underscore putchar dot c underscore putchar dot c. So that's the content. Don't worry, even if it is not clear here, just click on the Google documents in the description box. Click on the Google document in the description box, and you are going to get this everything that you need here. You're going to get it in the description box. All right. Yeah. Click escape. Colon Q. I want to save without quitting. You can do it this way. Okay. So once you have created your readme, you have created your main.h, you have created your underscore putchar.c. There's something you need to know here. Please pay close attention. You are required to create all these files. All these files. 0-I 0- is upper.o, 0.memset.o, 0-strcard.o, 1- is digit.o. All these files are the object files that are meant to be inside the library that you are creating, which is this library, my library.a, and they decided to do it as libmy.a. So these object files are meant to be inside this library. But before you create an object file, you ought to have a C file. You ought to have a C file in order to create an object file. How do you create your C file now? Well, looking at this, all the tasks that we've done, that you've done previously, your C files are already inside. It's just for you to go there one after the other, start opening it. You can check and search for all these files. All you need to do is just to replace this .o with .c, 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 and then you find out that all these files, you have them. You have all these files here. But I've made it easy so that you don't have to go and start searching for all these files. So what you just do, you go to the Google document that's in the description. You will see this 0 is upper.c, 0memset.c, 0strcat.c, 1 is digit.c. All these files, you have to create all of them. You have to create all these files. All right. So that is the next thing that you have to be doing now. After you've created your readme, you've created your main.h, you've created your putchar.c, just go ahead and start creating all this file. It is important you need to create all of them from the beginning to the end, from this 0 0 0 1 1 1 100 2 2 2 3 3 3 3 4 4 5 6 9. You need to create them. You also need to create the putchar.c, but we already did that here. Okay, so just create all these files and make sure that they are present in your web terminal. Make sure they are present in this box right here. So let's just start going through them one after the other. 0-i is upper.c. When you create it, you can just come here and you copy this code all the way from the include main.h hash include main.h. You can copy it all the way down to here. Please do not copy this line. Do not copy this line. I only used this line to show you that this code here is different from this code here. So please don't copy this line. What you're copying is from include main.h down to the last curly bracket. So when you do that, you vi 0 dash is upper dot c, then you see that what we have here is exactly what we have here. Okay, so I'm quitting. All right, quitting. So we do the same thing for this 0 dash memset.c. So you copy the code here all the way to this last curly bracket here. So you're copying this file here this way from the include main.h to this last curly bracket. Whenever you see this line, know that the code has ended. Alright, next thing you do is the 0-strcard.c. You do the same thing, you copy it down to this place. So when we are VIing into this, sorry, not supposed to do this. So when we VI into this 0-strcard.c, okay, when we do that, please pardon my baby, he's having his own fun. He doesn't know he's disturbing us. Sorry about that. Okay, so we create this file as well. Mind you, we're also creating, mind you would have created this one before you start creating this one. Just basically create all these files. Create all these files. 1 dash is digit.c, you create it. 1 dash memcpy.c, you create it. 1 dash strncat.c, you create it. 0 dash atoi.c, you create it. 2 dash strchr.c, you create it. 2 dash strlen.c, you create it. 2 dash strncpy.c, you create it. 3 dash is lower.c, you create it. 3 dash puts.c, you create it. 3 dash strcmp.c, you create it. 3 dash strspn.c, you create it. Just make sure you are following everything to the last curly bracket here, and when you see the line, you know that the code has ended. You do the same for this, 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 do the same for this. Then remember your readme. Like I said, you can actually put anything. I'm yet to update this readme the way I normally do my readme. Alright, you go to main.c, you go to main.h, that we already created. This is the main.h. All these are the prototypes that are meant to be inside your main.h. You can actually get your prototypes from here. They already put it there for you. Okay, so get all your prototypes. And then into your main.h. Okay, get all your prototype into your main.h. One sec. Okay, so that done, we'll move on. Then this is for number 2. This is for your second task. This is the code that is meant to be in the file that you create in your second task. So let's go back. Once all of this is done, okay, once all of this is done for the first task, once all of this is done, what do? We'll go and see what we are required to do here. Alright, fine. Once you are done creating all of your C files, there's something I want to show you here. Once you're done creating all of your C files, I want to ls so that we can see the content of the repository. You can see from here we have all the C files. I is upper.c, 1 is digit.c. Remember I told you that you are required to also create all these object files that are here. They need you to create these object files, but you can't create the object files if you don't create the C files. Okay, so your first step, you create the C files first, then you come to create the object files. So how do you create your object files? It's not by using vi and then copying the codes and putting it there again. Don't do that. There is a code for you to create it will just generate object files for all of the C files that you see here. And what is that code? Is gcc space dash c space star space dot c. This code, please copy this code. Here it is, gcc dash c space star dot c. You are going to use this code to generate object files. You're going to use this code to generate object files for all of your C files. Once you do this and you click enter, all these C files that you see here, an object file will be generated for them automatically. So you can just go ahead and do that. gcc-c space star.c. Once this is done, object files will be generated for all of these C files. And remember, the object files that is going to be inside of your library. Please just follow these steps gradually, follow it meticulously so that you won't have error when you are checking your codes. Alright, so gcc-c space star, that's for you to do what? To generate the object files. Alright, so once your object files are generated, what's the next thing for you to do? You come down here in your tags page. You are going to see or the files that they asked you to create here. There are two files that they require you to create here. The first file is mylibrary.a. They just tabbed it libmy.a. The second file is main.h. Remember, we've already created our main.h here. Where's that place? We already created our main.h here. Okay, so the main.h contains all the prototypes for the file that you are creating. So that done, what's the next thing to do? We'll come and see how we can create this mylibrary.a. It's a .a file, it's not a .h file, it's not a .o file, neither is it a .c file. So the way you create it is different from the way you create the rest of the other files. So how do you create this file? How do you create this file? Hey. Sorry about that. I had to reduce the noise. It's a full house. Sorry about that. Okay, so how do we create the .a file? We do that by using the simple code arcs, the name of the file. You click enter. You are creating the library, mylibrary.a file. Remember, arcs, the name of the file. So once you create the file, the next thing that you are required to do is to copy all the object files, all these .o files. They have to be inside your library because this is the main thing. This object files is what a compiler is going to use, is going to link to connect. Maybe you want to use these object files for an application that you are building or something, or anything that you are working on. The library will contain all the object files that a compiler is going to link to that application that you are building or anything that you are working on. Okay, so you have to copy all the .o files to your this new file that you just created. How do you do that? You simply type the same rcs space the name of the file space star or asterisk, as you might want to call it, .o. What does this do? .o. What does this code do? This code just checks inside this directory 0 times 09 static library. It will search for every .c file that is inside here, and then it will convert it into it will generate an object file for each and every one of them, including this picture. So as you can see, each of them have an object files here. This is how you create it. arcs libmy.a star.o. This is how you generate object files for all of the C files here. So you can just go ahead and do this. As I highlighted it so you can see it clearly. Just type the code and then do it. Once this is done, the next thing that you do, you can test the code. The command for testing the code is given in the tags here. So you just go to the tags here and you can run test for this code using, for everything that you've written, you can run a test for it using this code ar-t mylibrary.a. That's the first test you are going to run. So once you click enter, first of all on this one, it's going to generate object files for all of them. So you could just click ls to be sure of that, and you will see that every file here now has what? An object file. C I is upper.c, I mean 0 is upper.c has an object file, 0 memset.c has an object file, 0 strcat.c has an object file. Please ignore this one, just ignore it. 100 atoi.c has an object file. You know, all of them. Please make sure you create all these files. If you miss one of these files, your checker might not check. It will just be showing you error, 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 error. So ensure that you create all of this file to the latter in order for your tags to be checked 200%. Okay, so like I said, you can test it with this code here. Alright, so once it shows you all these object files here, it means that you did everything correct. Okay, you can also still check with this code here. That's for the second check. You can copy this and paste it here. It checks also means that you did everything correct. So let's clear our working space. So if you have done this to this point, the next thing you need to do at this point, you can just git add, git commit, and git push. There is a code I use in doing that. There's a code I use in git adding, git committing, and git pushing. Anytime I want to, I don't like doing git add dot then git commit dot git push. I like things very easy. So what do? I go here. Okay, so I use this code here. I git add, git commit, and git push all in one line. Okay, just using the ampersand to demarcate them. So you can change the commit message in here. Sorry. Alright, I like to use updated in this place. So click updated, and by the time I click here, it will push every single thing that we've created into my GitHub. So I don't need to start doing git add dot space, git commit dot space, git push. I just use the ampersand and do everything in one line. Okay, so once this is done, what are we doing next? You can check your code for that one, and you see that you've gotten 200% clear in that one. So what's the next? The next thing is we go to the second tax. The second tax, which is without libraries, what have we? We have no past, we have no future. Of course, anything you did not document, you are permitted not to remember when you need it. So the next thing we need to create here, the next file we are creating here is this file inside this directory. So we're creating this file inside this directory. How do we do that? The same way we created the .c files is the same way we are going to create these files here. Right. There's a little bit of an error here, but it's good it came up. Whenever you encounter something like this, please there's a simple thing you can do. Just use your R, capital letter R, and then you can recover whatever file that is there before the error happened. Maybe I was trying to open that thing and I was logged out or something, so it's registered an error. So I can recover it with this, and I can always save it using my column escape column WQ. I can save it, and so we'll create that file. So when you create that file, .sh file there, once you create it, the very next thing you need to do, I'm sure we saw the content of that file. It is here. See it here. I put it in the document file that is in the description here for you. So you just copy this, you just copy all of this and put it inside this file that you just created using VI. As you can see, it's more or less a compiler code, a compile code that writes that compiles the file into this .o, and also compiles a random library created into it. It also creates a random library and a library all.a. I'll show you where that is located, because if you do ls, you can see these files here that we did not create them by ourselves. See these two files, this lib.a and see this lib.a. We didn't create this file by ourselves, but this compile code inside here created this random library. Sorry, it created this library all.a. It's the one that is going to generate it, and that will be done when you create this file .sh and then you put this code inside. It's going to generate this file here for you. Okay, so once that is done, once you've gotten to this point, you've created this file and then you have put in this code here inside that file. The very next thing that you need to do in this case is to make sure that it is executable. Make sure it's executable, because as you can see from all the files listed here, that's the only file that is green in color. What does that mean? It is an executable file. So how do you make a file executable? You change the mode of the file by using chmod space u plus x, then you put the name of the file. If it is create whatever that is there, you put it and you click OK. By the time you ls, you will see that every other file will be white, only that file will be green. Okay, I can show you something else. You can, but maybe it's not important for this, but let me just show you. You can change the mode of all of the files inside your this thing by doing chmod. When you do star, all the files inside that directory will turn to green. I don't want to do that now because it's going to make me to start changing everything to anyway, let me just do it. It doesn't change much. So if I ls here, you'll see that all my files are green except for this directory. I told you forget about this directory, it's not for you, okay? So just forget about it. So you see that all the files have turned green. How do you reverse this? Change the mode again, chmod u plus x, no sorry, chmod, now you want to reverse it, u minus x asterisk. So it changes everything back to white. But remember, I want this file to be in green. Don't leave this file without making it executable. So we're changing the mode back, chmod space u plus x, then we'll put the name of the file. Okay, when you ls, you see that every other thing have changed. It's only the file that is green. Okay, let us clear this. So once you have gotten to this place, the next thing you might want to start testing your code to make sure that they run perfectly. Test all your codes and make sure that they run perfectly. You know how we test our codes now. Dot slash the name of the file. If it is 0 is upper, 0 is lower, any one that is there. Let's use this for instance. Sorry, let me look at the files that are there. If I want to check this file, I can do this. Let me use 5 dash str str.c. Okay, permission denied because it is not an executable file. That is for this one. We've not granted permission to that file, so that is why it is the way it is there like that. Or what about this one that we granted permission? Let's try it. Dot dash create. You can see it is working. Alright, so there we have it. So after you've done this now, you also do what? Git add, git commit, and git push. Remember we used that one line updated. You can just copy it, put it here. Change this to what? Updated. Then once you click enter, there's some untracked files here. There's some untracked files. Oh, those files that I created, I double created them because they were there before. Don't worry, I'm going to get them off. But if you created just the way that I created those ones, you won't have all these untracked files coming up. Okay, so just ignore that. It's not going to go to my repo. I use that one as an explanation, as a tutorial for you. So all those untracked files, I'm going to get them out, and then those other ones, I'll put them where they are supposed to be. So if you did this to this point, you git add, git commit, and git push, you can go and start checking your codes. Everything should check out 100% for you. So this has brought us to the end of our tutorial today. Be sure to subscribe for solutions to hard tasks that you are finding very difficult. Subscribe to the channel and click the notification button so that you get updates whenever I drop a video on this channel. Alright guys, see you next time.